Okay, so we're looking at the second year Stats and Mechanics textbook. We're on exercise 6, which is on projectiles, chapter 6, which is on projectiles, and exercise 6b, which is on finding horizontal and vertical components. Okay, so we are, get a sketch up. Okay, so we are projecting from the top of a building, and that's the horizontal. It is being projected with an initial velocity of 28 meters per second at an angle theta below the horizontal. So similar to question 2, it's going downwards like that. And that velocity is 28. Okay, so then we've got a situation. So as with the previous questions, I want the horizontal, so that's going to be to the right, and the vertical components of that. So the vertical component is going to be downwards. So again, they haven't told us what theta is, but they have, so let's draw the triangle kind of the same orientation. So they haven't told me theta, but they have told me tan theta is 7/24. And again, I know that tan is opposite over adjacent. Okay, so as I said, if you looked at the solutions, the video for question 3, if you did inverse tan of 7/24 into your calculator and then did sine of that, you will get the correct answer, but this is sort of the proper way to do it. Okay, so if I say, okay, so I'm not drawing the triangle from the question anymore. I'm just drawing a triangle with theta, where tan theta is 7/24. So if this is my angle theta and tan is opposite over adjacent, so this is my opposite side. So that, I don't know what I did there. It's my opposite side. So that's 7. This is my adjacent side. So that's 24. And then I use Pythagoras. I'll just do it on the calculator. So 24 squared plus 7 squared, all square rooted, then gives me a hypotenuse of 25, which means I can then say, so I know that sine is opposite over hypotenuse, so that's going to be 7/25, and cos is adjacent over hypotenuse, so that will be 24/25. Okay, so that's sort of the proper way to get those values, if you like. Right, okay, so let's go back. So I haven't even read the question. I'm assuming it says the same as the other ones. Yeah, so we want the horizontal and vertical components, and then we want to write it as an I and J vector. So horizontal is, so I'm looking at the side that's adjacent to theta. So that's going to be 28 cos theta. And this one is opposite. So this is going to be 28 sine theta. So scroll up a little bit. In fact, let's just move this up a little bit. Okay, so the horizontal velocity, so I'm using u for initial velocity with the subscript h to show it's the horizontal. So 28 cos theta is going to be 28 times 24/25. So 28 times 24 divided by 25. So to 3 significant figures, I'm getting 26.9 meters a second, and that's to the right. And then the vertical velocity is down, and that's, so I'm looking there, that's 28 sine theta. So that's 28 times 7/25. And I'm getting that to be 7.84. And then that's down. So I can either put down, or I can put a minus there to show that that's down. But really, this is what question B is. So we've done all the calculation for B. But if I want it as a vector, the horizontal is my I component. So 26.9 is the I component. The vertical is the J component. And because it's down, it's going to be minus 7.84 J. And then let's include the units as well. Okay, so just double check that. 26.9. And so again, they've gone to 2 significant figures, but really we should be going to 3 significant figures generally if we haven't used G.